Now let us find the total surface area and volume of this rectangular pyramid. That means here the base is a rectangle with dimension 10 meter and 8 meter. Since these two dimensions are not equal, so this base is not a regular polygon. So since it is not a regular polygon, the total surface area we will calculate as the base area plus all side faces area. This is always true, but this all side faces area, now we need to calculate each of the side face individually. So if we name it O, A, B, C and D, then this OAB, OBC, in this individual face we need to calculate individually, and each of the face area, each of this face area we will calculate using this formula, that half of its arm length and its slant length, and the volume of the pyramid will be half of the 1/3 of this base area times its height. So now let us see what are the dimensions we are given and what are the dimensions we need to find out. Okay, so for this OAB face, its arm length is given and this slant length is also given. So we can calculate the face area of this OAB, face. And for rectangle, this AB and CD are equal, so OCD and OAB, these two faces area will be same. So if we calculate 1, just multiply by 2, we'll get the twice. And for OAD, this face, and OBC, this back face, they are, for rectangle, these two arms are equal, so they will be identical. So if we calculate just one of them, we can find the other one. Now to calculate this OAD, this triangle's area, we need this AD, which is 10 meter, and we need this slant length, which is not given. So let us assume this slant length is L. And to calculate the volume of the pyramid, we need this height H, which is also not given. So this height and this slant length on this AD arm we need to find. So let us find these two dimensions first. So if we name this center as X and this point as P and this point as Q, let us do. So OX is the height which will be perpendicular on this line PX. So in this triangle, if we draw it a little separately, PXO and this slant length OP. So here we need to find this height H. Our OP, this slant length is given 13, and this PX is half of this AD, because this side it is covering just half the distance. So this PX will be half of equals to this AQ, which will be equal to the half of this 10 meter. So this PX is 5 meter. Now this is right angle, so this is hypotenuse. Using Pythagoras theorem, we will get 13 square equals this H square plus 5 square. So from here, if we calculate, H square will be 13 square means 169, 5 square means 25, which is 144. So H we will get 12 meter. So the height of the pyramid we found 12 meter. Now we need to find this slant length. For that we will be using this triangle OXQ or QOX. Here this OX is perpendicular on this line QX. So if we draw that triangle, that QX, this is Q, this is X, and this is the height O. So now this height we know is, which just we found 12, and this QX, which is equal to AP, which is half of this AB, which is 4 meter. So this is 4 meter. Now this L, this OQ is the slant length L we need to find. So this is right angle, this is the slant length, so L square equals this arms square plus this arms square. So 12 square plus 4 square. So from here we will get the slant length L equals square root of 12 square plus 4 square, which will be, if we calculate it, we will get 12.65 meter. So this slant length is L equals this, and this slant length is given. So let us actually name them as L1 equals this slant length, and let us name it L2. So it will be L2. Since we got two defined slant length, let us name them as L1 and L2. This one is L1, this one is L2. So now we have all the dimensions needed. Now we will be starting calculating the areas and volume. So now this area, OAB faces area, will be half face area, half arm length times slant length. So half arm length is 8, slant length is 13. So the area of face OAB or OCD, these two area, that is area of AOB or area of, let us write OAB or OCD, they are same because it's a rectangle AB and CD same. So OAB and OCD, these two faces area will be half of 8 times this slant length 13. So half times arm length times slant length, it will be 52 meter square. And area of OAD or OBC will be half of this arm length is 10, and this slant length L2 we just found 12.65. So area of OAD or OBC will be half of its arm length is 10 and slant length is 12.65, which will be 63.25 meter square. So the all side faces area will be, all side faces area will be 2 times of this, because each of this is this and there are 2 of them. So 52 plus 2 times of this, 63.25. If we calculate it, 230.5 meter square. Okay, now this is all side faces done. Now we need to find this base area also, because total surface area will be base area plus all side faces. We just found this one, so we need to find the base area. Base is a rectangle, so its area will be this sides times this side, so 10 times 8. So base area is 10 times 8, which is 80 meter square. So now the total surface area is base area 80 plus all side faces area 230.5, which it will be 310.5 meter square. So the total surface area is 310.5 meter square. So now the volume relation is 1/3 times base area times height. Height we found here, we were not given, but we calculated it, 12 meter, and base area we just found 80. So volume will be 1/3 times base area, which is 80, and height we found 12. So if we calculate it, we will get the volume as 320 meter cube. So here in this example, we learn that if the base is not regular polygon, then we need to be considering individual arms with their own merits and calculate each of the face individually. Or for example, for this rectangular base, this arm and this arm, their faces are similar, so we just calculated one, and AD and BC, their corresponding faces are same, so we just calculated one and then multiplied by 2. So when there will be a non-regular polygonal face, we will be calculating the each of the faces area using this formula, that is its arm length and its slant length, and the slant lengths will be different between arms to arms. And here in this example, we also saw how we can use different inherent right angle triangle to calculate unknown dimensions from the given dimensions.